Hi everyone, in today's video I'm going to cover exponents and all the rules associated with them. I have 9 examples written out. I'm going to show you how to solve each exponent and show you the rule that goes with each one too. So the first one I have is 2 squared. So with 2 squared, what that really means is it's 2 times 2. So we're going to do 2 times 2, which is equal to 4. And 2 squared is equal to 4. And so this is just kind of the basic rule of what an exponent actually is. And so we're just going to kind of go through the rest of them now, and I'll show you how each one is a little bit different. So now 2 cubed. It's very similar to the first problem, 2 squared, except this time we want 2 times 2 times 2. So it's going to be equal to 2 times 2 times 2, which, 2 times 2 we know is 4. Times 2 one more time, that's equal to 8. So, it's very similar to the first rule. You're just multiplying out the base, which we call the base and the exponent. So now, these next examples are all a little bit more complicated. So 2 to the 1/2 power. So, as you notice in these first 2 examples, I just have whole numbers as the exponents. 2, 3. But what these exponents really are, you could write it as 2 over 1 or 3 over 1. And so, going along with that, 2 to the 1/2, it's 2 to the first power, which I have as another example. I'll just tell you guys now, it's 2. But we have to the 1/2 power. We have the 2 as the denominator in the exponent. And what that's saying is we're going to kind of work the opposite way of exponents. Instead of kind of multiplying, or squaring 2, we're going to square root 2. So it's actually equal to the square root of 2. Now for the next example, 2 to the 3/2 power. So, we know since we have 2 as a denominator, we're going to use the square root function somehow. But now we have this 3 as the numerator. And in this, in these first examples, we also had whole numbers as the numerators. So we're going to kind of combine both rules now. So what this is saying is we want to find the square root of 2 cubed. So the way that works, you use the numerator to determine what you do with the base. Whether how many times you're going to multiply by 2. You use the denominator to determine kind of what power you're going to square root it by, or what power you're going to kind of root it by. So in this example, we're going to do the square root of 2 cubed, which is equal to the square root of 8. And we can simplify this into 2 times radical 2. So for this next example, I'm going to go over 2 to the negative 3rd power. So this time it's going to be a little bit different than before, where with the negative power, you're going to end up doing 1 over whatever you would get if it was a positive power. So this is actually equal to 1 over 2 cubed. So whenever you have a negative exponent, you're going to get a fractional answer. So it's going to be equal to 1 over 8, since that's what 2 cubed is equal to. Now we're going to kind of combine the fractional rules and the negative rules in this next example. 2 to the negative 1/2 power. So similar to before, we're just going to do 1 over 2 to the 1/2 power. And we know that 2 to the 1/2 power, from this example, is just square root of 2. So it's going to be 1 over square root of 2. Now we're going to kind of combine even more of these rules in this next example. 2 to the negative 3/5 power. So we know it's going to be a fraction to begin with. So it's 1 over 2 to the 3/5. And using these same rules from this problem and from this problem, we know that it's going to be 1 over, and this time instead of the square root of 2, it's going to be the 5th root of 2. So it's going to be 1 over the 5th root, and using the numerator, 3, 1 over the 5th root of 2 cubed. So it's equal to 1 over the 5th root of 8. And these cover all of the basic rules with exponents. The next two examples I have are just kind of very simple, basic, almost types of things you memorize. So 2 to the first power, anything to the first power will end up just being itself. So 2 to the first power is equal to 2. 3 to the first power would just be equal to 3. 100 to the first power would just be equal to 100. Then for the final example, 2 to the 0th power, that's just equal to 1. Anything to the 0th power is equal to 1. So once again, 100 to the 0th power, that's equal to 1. It's equal to 1. And then, 1 million to the 0th power is equal to 1. So that covers all of our basic exponent rules. Look at all of our other videos for additional help in math. Thanks for watching.